Welcome everyone to BTT 151 Fundamentals of Electricity. I'd like to go over your Unit 2 homework. Question 1, the impulse of electricity is very slow. That's false. Question 2, metric units of measure are used in the electrical field just as they are used in most scientific fields. That's true. Question 3, the symbol used to represent a resistor on an electrical schematic is standardized. That's true. Next question, 4, 0.00045 amperes is equal to 45 milliamperes. That's false. The correct response would be 0.045 amps. Remember, milli is 1/1000th of something. Question 5, 0.0075 milliamps is equal to 7.5 microamps. That's true. Question 6, what is a coulomb? Coulomb is a unit of charge, or the quantity of electrons. Question 7, what is an ampere? Ampere, 1 coulomb per second. Next question, number 8, what is an ohm? The ohm is the unit for resistance. Question 9, what is a watt? The watt is a unit of power. Question 10, electrical heating element has a resistance of 16 ohms and it's connected to a voltage source of 120 volts, asking us to solve for the current. Current I is equal to voltage V divided by resistance R. Plug these numbers in, we'll get a current of 7.5 amps. Question 11, how many watts of heat are being produced by a heating element that has a resistance of 16 ohms and a voltage of 120 volts? This time we're going to use a power equation. Power P is equal to voltage V squared divided by R. Plug these numbers in, power is going to be 900 watts. Next question, question 12. 240 volt circuit has a current flow of 20 amps. How much resistance is going to be in that circuit? Again, we're going to use Ohm's law. Resistance R is equal to voltage V divided by current I. The resistance would be 12 ohms. Question 13. An electric motor has a resistance of 15 ohms, current of 8 amps, and it's asking us to solve for the voltage. Ohm's law, voltage V is equal to current I multiplied by resistance R. So the voltage would be 120 volts. Next question, question 14. A 240 volt air conditioning compressor has an apparent resistance of 8 ohms, and it's asking us what the current is. Current I, again, is equal to voltage V divided by resistance R. So we plug our numbers in. Current will be 30 amps. Question 15. How much power is being used by a compressor when it's connected to an electrical supply of 240 volts and a resistance of 8 ohms? So power is going to be equal to, in this example, I squared, the current squared, multiplied by the value of the resistor. So we should get a power of 7,200 watts. Question 16. A 5 kW electric unit heater is connected to a 240 volt line. What's the current? Most important consideration always to keep in mind, we have to get everything in base units. 5 kW, K is kilo, that's 1,000. So we have to convert 5 kilowatts multiplied by 1,000. 5 kilowatts is equal to 5,000 watts. From that, we can go ahead and calculate the current. So in this example, current I would be equal to the power P divided by the voltage V. So we would get a current of almost 21 amps, 20.83 amps. Next question, question 17, same units. 5 kW electric unit heater is now connected to a 120 volt circuit. What's the current? Current would be double of the current we had found in the previous problem, 41.67 amps. Question 18, which of the following is not a fixed type of resistor? The metal composition resistor. Question 19, what's the advantage of a metal film resistor over a carbon resistor? The ohmic value of the resistor will remain relatively stable over an extended period of time. Question 20, what's the advantage of a wire-wound resistor? They can handle very, very large blocks of power. They can dissipate a lot of energy. Question 21, how should tubular wire-wound transistors be mounted? Vertically. Question 22. A half watt 2000 ohm resistor has a current flow of 0.01 amps through it. It's asking us to calculate the power. So power is going to be equal to, in this example, the current I squared multiplied by resistance. We plug these numbers in. We're going to get a power of 0.2 watts. Next question, question 23. A 1 watt 350 ohm resistor is connected to a 24 volt supply. What's the power dissipated? Power P is going to be equal to voltage squared, so V squared over R. We plug these numbers in, and we will get 1.05 watts. Question 24. A resistor has colored bands of orange, blue, yellow, and gold. What's its resistance value, and also what is the tolerance? Resistor value would be 360,000 ohms, or 360K, and it would be a plus or minus 5% tolerance. Question 25. A 10,000 ohm resistor has a tolerance of 5%. What are both the minimum and maximum ratings? All we have to do is take 5% of 10,000, add that and subtract it from the original value. So the minimum value would be 9,500 ohms, maximum value would be 10,500 ohms. Next question, 26. Is 51,000 ohms a standard value resistor with the 5% tolerance? Yes, they are. Question 27. A 1500 watt heating element has a resistance of 38.4 ohms, asking us to calculate the current. Power P is equal to current squared, I squared R. So we're going to solve for I. So I is going to be equal to the square root of power divided by resistance. We plug these numbers in. Current is going to be 6.25 amps. Question 28. That same heating element, a 1500 watt unit, again with resistance of 38.4 ohms, asking us now what the voltage is. Well, we know power, we know resistance, and we also know current that we had calculated previously. So I could say P is equal to I squared R. I could also use equation P is equal to V squared over R. Plug these values in. Voltage, 240 volts. Next question, question 29. A 100 watt lamp is connected to a 120 volt circuit. How much current would flow? So again, we're going to use our power equation. I is equal to power P divided by voltage V. Current would be 0.833 amps. Next question, this would be question 30. 15 watt soldering iron is connected to a 120 volt circuit. What's the resistance of the iron? So again, Ohm's law. No, actually we're going to use our power equation because we have power specified. So P is going to be equal to V squared, voltage squared divided by R. Plug these values in. Resistance value 960 ohms. Next question, question 31. A 300 watt heating element is connected to a 277 volt line. What's the current that will flow in this circuit? Power P is equal to voltage V multiplied by current I. We solve for current I. I is equal to power P divided by voltage V. Plug these numbers in. Current would be 1.08 amps. And then the very last question, question 32. A 1.5 k ohm resistor has a current of 8 milliamps flowing through it. What's the voltage? First approach, remember, 1.5 k multiplied by 1,000 is 1,500 ohms. 8 milliamps divide by 1,000, so 0.008 amps. So voltage V would be equal to current I multiplied by resistance R. We plug these values in, and our voltage should be 12 volts. Thank you.